Welcome to Difficulty and Playtesting. In this video we're going to create a facility to map the length of the words to the maximum number of tries so that we can change our hidden word quickly and easily and have an appropriate number of tries. And we're going to discover what that appropriate number of tries is by doing some more playtesting and that is effectively what's called play tuning the difficulty of our game. Now, why do we want to tune the difficulty of our game? Well, if you do a Google image search for Flow Channel, you'll get a bunch of different results, but most of them will be relevant. So here's an example of the diagram. Let's imagine we start off with a low challenge and a very low word length. If we just increase the word length without adjusting the number of tries, then the game could get too difficult. If you had, say, a 3-letter word with 3 tries, but then you went up to a 10-letter word with only 3 tries, it would just create anxiety. It would be nearly impossible to play. Similarly, if we just increase the number of tries too high without increasing the word length, then we are going to just get a very boring game. You don't need 100 tries to guess a 3-letter word. So the idea of the flow channel is you balance those two. So as our word gets longer, the challenge goes up. Then we need to also increase the number of tries so that as the player's skill goes up, they can increase the word length up the challenge axis and still stay in flow. Otherwise, as their skill go up and they feel like increasing the word length, then the challenge won't actually get any higher, or it'll get high too fast if the number of tries doesn't change. I hope that makes sense. It's relatively simple. You just need to be careful about what's on each axis. The basic point is to keep it fun by keeping it challenging. So we are really on the home straight here, but there's one glaring omission, which is there is no difficulty tuning whatsoever. We have a 6-letter isogram in this case, and I've arbitrarily set my number of tries to 3, which is of course impossibly difficult. So let's implement a very simple system so that when we change the word, we change the number of tries. And I'm going to help you implement that now. So guess what we could use? We can use a map again, right? So how are we going to do that? Well, where would we code this? Well, under get max tries would make sense, right? Where we implement get max tries, which we declare here, and then implement right here as a simple return. Why don't we make that a little more complex and use another map? So I'm going to move it down just above the reset method, just for simplicity. I'm going to remind myself that this thing at the top here is the default constructor, because it's quite easy to say, why do we need that? Let's get rid of it. No, that is the default constructor. It's called when the object's created. And here's the method. So rather than returning max tries, why don't we flesh this guy out a little bit? How about we make another tmap? And how about it's of type int32 to int32? And we call it something like word length to max tries. Nice and descriptive. And we can actually use something here called braced initializer syntax. So rather than going through and doing inserts, there is a syntax in C++ which uses braces to initialize. Now, you can actually use braced initializers anywhere. You could, for example, instead of say int max tries equals 3, you could say equals braces 3, or you could leave out the equals. It's pretty redundant when it comes to single elements like this, although it is considered by many to be good practice. But when it comes to a collection of things like this, like a map of the word length to the maximum tries, this is going to be a really easy way to initialize this. Let me show you how we'd do it. So I'm going to start assuming the shortest word we have is, say, 3, and I'm just going to give them all 5 tries because it's going to be your challenge to find a reasonable mapping. So for a 4-letter word, we'll give them 5 tries, and for a 5-letter word, we'll give them 5 tries. And for a 6-letter word, we'll give them 5 tries. Very boring. Of course, you wouldn't do this, but it's a starting point. I'm trying to get the data structure in place. If you've got that in place that maps the word length to the max tries, word length, max tries, word length, max tries, then you can, with a bit more consistent spacing, very simply return this, of course. We can just return now, small r, word length to max tries. Remember, use square brackets to access the elements, and then we're going to call upon my hidden word dot length. Can you see what we're doing there? We're passing in, we're accessing the element by this first pair in the mapping, by the word length, and it will return us this here. So now getMaxTries does that. Fantastic. So with a 6-letter word, well, with all of them, we're expecting a return value of 5 tries, which we get there. If I was to change this to 15 or something conspicuous as a test, then I get 15 tries. And if I was to, say, go back down to a 5-letter word, I like planet because it makes so many subwords, plane and plan. Here you go, 5. So it does appear to be reading this properly, and it's a very simple method. And of course, what it means is we no longer need here to have my max tries. We just don't need that as data anymore because the data is stored here right inside the method that returns the number of tries. It's the only place we need it, so let's keep it tight right next to where we use it, and then we never see it again and we never have access to it again. So similarly down here, we don't need a constant for my max tries. We don't even need that there. So we can just go hidden word, current try. That's the initialization. All of the stuff about getting max tries is here, and we've simplified our code, removing lines actually, whilst still improving the functionality. So, pretty cool. What I want you to do now is to map your word length to your max tries. Populate your word length max tries map, and write the code I just wrote if you haven't done already. Do more playtesting to find the sweet spot for each word length, ideally with a couple of different people. Try and see, what we want here is that the word length determines the difficulty of the game. And then at a given word length, like 5 letters, it's a fixed difficulty. In the next version of the game, in the next section, we may add another dimension so that at a given word length you can even choose the number of tries. But for now, let's keep it simple. Do this for at least 4 to 6 letter words. Map at least 4 to 6. I'm probably going to map 3 to 7 letter words. And optionally, but this is only a bonus option, and only if you're really comfortable with what you're doing, let the user select their word lengths. You could have a map of words, right? You could say if we have a 4-letter word, it's this, and a 5-letter word, it's this, and a 6-letter word, it's the other. But I'm not even going to show you the solution to that. So unless you're confident and you want to test it yourself by having it work, then don't do it. But if you want an extra challenge, go ahead and do that and test it works yourself. It's using all existing knowledge. So see you in a moment. Welcome back. So through playing the game multiple times, albeit with my wife who's quite good at these games, I came up with 4 tries is enough for a 3-letter word, 7 tries is enough for a 4-letter word. You need about 10 tries, I think, for a 5-letter word, maybe 15 tries when you get to a 6-letter word, and I think finally we'll just go for a 7-letter word, at which point I haven't spent a lot of time testing this one, but I think 20 tries may be enough. So here we have a map. Great. And let's just check plain. Well, let's just work through plan. PLA should come out at 3. I'm only going to test a couple of these. 4 rather. Yeah, 3-letter word gives 4 tries. That's correct. And let's just go up a couple. PLANE. That's 5. Should give me 10. And it does 10 tries. Let's also make sure that those 10 tries work. So PLAN, I don't know, K or something. Plank, plank, plank. I should have done this on the shorter one. I'm going to do it on a shorter one. But frankly, is there any need? So my temptation there is to go and test that the game ends, but the game will end, and I'm going to stay confident in that because we have only changed the inside of getMaxTries, which still returns an int32, and all of the other logic hasn't changed. So I'm confident it will work, and I'm not even going to test it. Is that a good practice? Is that a bad practice? Difficult to say, right? Because we are very confident that we've only made a local change here. In a commercial product, you may have automated tests in place which would check this for you. What is the correct kind of gut feel here? The gut feel is if you're in doubt, check it. So because that's what I've said, I am going to go and check that now, but I'm going to go and check it with a 3-letter word and make sure I only get 4 tries. PLA, PLE, PLD, 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 and don't play again. Great. I'm going to leave this as plain, I think, and that's enough. So fantastic. We now have a difficulty table, or at least a way of selecting different word lengths, at least hard coding different word lengths. As I said, it was an optional extra for you to ask the user for a word length, and you would have to create a couple more methods to map word lengths to given words. So well done, and I'll see you in a moment.